Oh, okay. Hey, you wild.
Okay, good morning. Last time we wrote something on the board. It's not clear, so let's repeat this part. Right? For parallel circuit, if you have two resistors in parallel, for example, we have one and we have two, and this is R1, this is R2. What I want is the total resistance looking from these two terminals to the right. Sometimes we said total, sometimes we said equivalent resistance. Later time we may want to use the equivalent resistance, but here we still use the total resistance. Right? If we have only two resistors, what is this? What is RT?
R1 plus R2.
The total of two resistors added.
No, you have to divide over.
R1 plus R2?
No, 1 over R.
Yeah, that's right.
Plus
1 over
R1
R1
plus 1 over R2.
The R2.
Wait.
plus R2, like this?
No.
No.
1 over R1 plus 1 over R2.
Wait.
Like this?
Yeah.
Okay, this is good. Right? So 1 over R1 plus 1 over R2. Right? But for two resistors, that's a very common situation. So we have R1 times R2 over R1 plus R2. So the product of the two divided by the sum of these two. Right? If we have three, another one. So we said this is 1, 2, and if we have 1, 2, 3, how to do this?
Use conductor.
Right? The better way is, as we already mentioned, use the total conductance equals the sum of individual conductance. Right? That means the G1, 2, 3 equals G1 plus G2 plus G3. That is the best way to do this. Right? And this one means 1 over R2, 3. This one means 1 over R1. This one means 1 over R2 plus this one means R over R3. Okay? So this one is equivalent to this. And this one will give us 1 over R1 plus 1 over R2 plus 1 over R3. Okay? So this one is very similar to what we mentioned before. And if you simplify this, this one will be equal to R1, R2, R3, and on the bottom that will be R1, 2 plus I2, R3 plus R3, R1. Right? It is in a pattern, but again, it's not a good way to do this. So we prefer use this one. That means we start from here.
So you use conductance, you don't put.
Use conductance. The total conductance equals the sum of all the conductance.
So they don't go on.
Don't use this method. This method is not. For example, if you have 4, then there's a 4 here, there's a 3 here, there are 4 terms. So we are going to have a lot of trouble. Right? So if we have 4, then this one 1, 2, 3, 4, you just add another. So once we are given the resistance, you convert each one into conductance, then add all this together, then take the reciprocal. That's very simple. Right? So for series, we just add all the resistance together. For parallel circuit, we add all the conductance together. That is the total conductance. Then we just take one more step. 1 over that conductance to get that. Does it make sense? Right? Yes. So this. Right? Today we are going to discuss current divider. Last time we mentioned a little bit. Right? Let me check if you still remember this. Suppose we have a current source. Right? That means this current is, we already know this. And if we have two resistors, okay, R1, R2, what I want is the current flowing through R1 and also the current flowing through R2. Right? The sum add up together from Kirchhoff's current law. This one coming into, this is one node, right? So coming into equals the sum on the outside. That means RF equals R1 plus R2. But what is R1? Anyone still remember this?
R2.
R2.
R2 over
R1
R1.
R1,
R2.
On top is R2 over
R1 plus R1.
R1 plus R2.
All
Times
times the.
Then times the total, right?
Yeah.
Okay, so that is I1. And in the slide, we said, okay, this is 1 here, so this is 2.
Right.
To keep in mind, that's the difference between current divider and voltage divider. If voltage divider, if this is V1, then this one will be a R1, and this is a Vs. And this part will be the same, right? And for I2, that one will be equal to R1 or R1 plus R2 times Is. So that is the current divider. Right? For only 2. How about for 3? For example, if we have another one, like this, is R3 here. How are we going to modify this formula? For example, we care only about the current on the first one.
G1.
Can you find out, give us a formula to do this?
G1 over.
Okay, yes, we use, as we said, we do not use this idea for resistance. Resistance is better used in series circuit. Right? So, parallel circuit, the counterpart is the conductance. Right? So what we have is this one equals, you just consider this voltage divider for series circuit. And in voltage divider for series circuit, that is easy. So this is R1 plus R2 plus R3, and on top of R1, so this is Vs. This is for voltage divider, right? So that is easy, right? But for current divider, right, we are looking for current. So this is a voltage divider, right? And then we discuss current divider for this parallel. This one will be I1 equals, we just replace all this R with G's. Still works. So this one will be G1 over G1 plus G2 plus G3 and Is. Just like this. Again, if we are given this R1, R2, R3, instead of conductance 1, conductance 2, conductance 3, we take one more step first. Okay? Convert this one into G1 into G2, G3, then we use this one. So this way you need only memorize one formula. Right? So in summarize, in series circuit, the voltage is proportional. In a series circuit, the voltage is proportional to the resistance. The larger the resistance, the larger the voltage. And in parallel circuit, anyone can guess? I
Is inversely
okay, inversely proportional is proportional to 1 over R, right?
Yeah.
That's called inversely proportional to R. But as we said, this is not good formula, right? So we do not use this R. Instead, we use a G. Right? So next time you see, especially if the circuit is very complex, has a lot of components, better convert into conductance first. Then this one is proportional to G. The larger the conductance, the larger the current. Okay. Any further questions on this?
So the bottom was the current divider?
This one is for current divider. Current divider is only for parallel circuit, right? Not for series circuit. Why? Because in series circuit, all the current are the same. So there's no way you divide, all the same. Again, voltage divider is only valid for series circuit. For parallel circuit, there's no voltage divider. Why? Because all the voltage are the same. If these three resistors are in parallel, the voltage are the same. You don't need to divide. Right? Okay. those are the formulas here. And notice the subscript. 1, the first one, 2. Keep in this mind. This is very trivial, but easy to confuse, especially in the test or something you are in a hurry to. So this is 1, this is 2, this is 2, this is 1. But this formula only works better used for 2. If you have 3, don't use this kind of formula. You use what we mentioned here. How about if special case? How about if all the resistors are the same? For example, if we have 2 resistors, the 2 resistors are the same value.
You can just get one multiplied by the number of resistors.
Yeah.
1 multiplied or 1 divided? I mean the current. Suppose you have 2 resistors in parallel, but these 2 resistors are the same. What is each current?
The same.
They are the same. Add up together equals total. So each one is the total divided by 2, right? If you have 3, all the same, then the each current will be equals to the total divided by 3. Right? If you have 10, later time you may have homework. Right? If you have 10 or more, no matter what, you divide it by the total number of resistors if they are equal. Does it make sense like here? If R1, R2 are equal, so this one, for example, equals 10, this one equals 10, this one equals 10, so this one equals half. Right? If they are 3 all the same, then this one fraction must be only 1/3. So that's easy. Same thing for series circuit. In series circuit, if the total voltage, for example, equals 12, if we have 3 same identical resistors in series, then each one is 1/3 of the total. So we use divided by n. N is the total number of resistors. Assume that R1 equals this parallel with R2, which is this. If the total is this one, what is the current in each? That's easy, right? So I1, memorize the formula, equals R2 on the top, the sum on the bottom times the total, and equals 5.45. And the second one will be R1 on the top. Still the sum on the bottom, then 2 times the total, which equals 2.55. Notice that the larger resistor have a smaller current. Larger resistor means smaller conductance. So that means smaller conductance has a smaller current. Larger conductance have larger current. Okay, electric power. In parallel circuit, to calculate the power, although we have 3 formulas, VI, V squared over R, and current squared times R, and maybe the better way is to use V squared over R. Can you see why? For example, if I give you 3 resistors in parallel, like the example we discussed before, the total voltage, for example, equals 12, and each resistor equals 1 ohm, 2 ohm, or 3 ohm, like this. How to calculate the power on each one? Which formula are you going to use? Right? V squared over R, right? Because the V is the same. Your is given, so just V then divide by each individual resistance. Definitely, you can use the current divider first, then try to find each current. Then you use the current squared times R, but that is extra. There are extra work involved, so we don't want to do that. So we have 3 formulas. You need to be able to find out which one is the first for each situation. Any questions on that? We may have an example to do this. As in the series case, the total power is the sum of the powers dissipated in each resistor. Question: what is the total power if 10 volts is applied to parallel R1, R2? Right, now everybody do this. A voltage source which is 10 volts applied to a parallel of R1 and R2. R1 is equals to 270, R2 equals to 150. So what is the total power? How are you going to do this? Okay, add the total. That means you need to find the power on each one. Right? First one, find the power on R1, P1. What is P1?
0.37.
Good practice is the first one you state the formula you use. Then you just plug into numbers, then find the result. So P1 equals
0.37.
V squared over R1, right? So which means equals 10 squared over 270. Does it make sense? Everybody see this? Okay. Then you plug into numbers. The calculation is very simple. Okay. Next one, P2 equals what?
10 squared over.
Equals V squared over R2. Right? The step one is you write the formulas. Then plug into number. Equals 10 squared over 150. That is like a 0.678, right? So what is the total? You add these two together. Make sense? So this is the one way. Or in this case, this one may be the better way. We have other ways to do this. But we do not want to calculate the current. Yes, you can use the current divider to calculate the current and use the current squared times R, right? Okay, we have another way to do this. We said the total power equals the sum of the individual power. We already used this method. Anyone can figure out another way to do this. Use the concept of total resistance or equivalent resistance. We consider these two resistors as one. This idea will be used a lot in later chapters. Now we introduce first here. So that means these two resistors, you can consider it as them as one, just in parallel. Does it make sense? So you just, what is the total resistance? It will be R1 in parallel with R2, right? So here is, again, I would like you to write in the homework or any like this. So the total resistance equals, theoretically, right? So equals R1 in parallel with R2. So you state clearly to me, you know the total equals R1 in parallel with R2. So I know you understand what we are doing here. Does it make sense? So you write this one. You don't need to write the word, okay? The total equals R1 and R2 are in parallel. That is the meaning of that sentence. Then equals R1 times R2 over R1 plus R2. Right? Use this formula here. Does it make sense? Okay, then you plug into numbers, which equals 100 times 150 over 100 plus 150. Okay, so this one looks like 60. Right? This looks like 60 ohms. Right? Because we do not use any, we do not write any unit here, so the last one is like this. Make this very clear, so the unit is this. Does it make sense?
Yeah.
Right. Then the total power will be equals, which formula are we going to use? V squared over R total, right? Alright, then you plug into numbers. V squared equals 10 squared over 60. Then this one will be equals like 1.67 amperes. Is this good? This is what I want you to write in your submission. Write the formulas, plug into numbers, give me the result. In case it said, okay, this one equals 16. If this was 10 points, I will give you 9. The only mistake is this point. Don't only give say, okay, the total equals nothing here equals this one. You give me 16, you get nothing. Okay, good?
Good.
All right. Look. Oh. No one putting any questions? This one is not 100. Right? So in this example, that's equals 270. The other one equals 100. So this one is only works for this, not for our example. Our example is this one equals 270. This one is 270. This one equals what? This one 270. I cannot do this. Anyone get this?
Calculator, anyone?
Anyone can calculate this? 60 something, right? No?
I don't know.
It's like 96.43.
80 something. 80 to 90 something.
It's 96.
96. Okay, good. I believe it. 96. 90 something. Okay, then this is 96. So this one 100. Okay, yes, that is will be 104. See, if I did something wrong like this, I can still get more than half credit, right? Because I just plug into the wrong numbers. But I know how to do it. Just my careless. So that's the benefit you write the formulas. Does it make sense to you? That's a good example, right? Okay. Assume there are two resistor wires that form a rear window defroster for an automobile. If it was dissipated 90 watts when connected with a 12.6 volt source. The power resisted by each resistor wire, what is the power on each one? Okay, now you do it. We have a total 8 resistive wires. Total 8 resistors. All are the same, right? Didn't say. We need to assume that they are the same. Otherwise, we cannot do this. So we assume all the resistors are the same. Otherwise, definitely we cannot do this, right? Anyone? What is A?
11.25 watts.
How did you do that?
I divided 90 by 8.
Divided 90 by 8. Who agree with this? Yes, okay, it's good. Why you divided by 8? Because they are identical, right? That's the condition. Okay? The total equals 90. We have 8 identical wires. So each one is because the total power equals the sum of each individual power, and all these 8 are the same. Does it make sense? Okay, good. So 90 divided by 8 equals 1.125, right? Yes, 1.125. Okay, next one. What is the total resistance?
1.76.
Tell me the formula first. I cannot decide equals 1.6.
Just reverse it. R equals P squared over P.
So how are you going to do it? Do this?
Because the formula is P equals equals V squared over R, right?
P equals V squared over R.
So we have
Yes.
P and we have V, and then, so R equals V squared over P,
Which P are you going to use?
the 91.
The 91.
Yeah.
Okay, so that means that the R is the total, right? That make sense to everybody?
Mm-hmm.
Yes or no?
Yeah.
Right. P total equals V squared over R, T, R total. So R total will be equals V squared over P. That will be equal to 12.6 squared divided by 90. We are talking about the total resistance, the total power, everything. Okay. What is your result?
1.76.
1.76. Okay, so 1.8, assume, right? That's it for this one. But I will ask a further question. What is the resistance of each wire?
Divided by 8.
Divided by 8.
2.
Oh, resistance of heat. Oh, never mind, hold on. That's on the rear window. Assume that they're eight resistors. They're all in parallel, right?
Parallel and method.
They,
No, not
it
divided.
didn't say it's in parallel. So the first question we should ask is are they in parallel?
Are they in parallel?
We will assume they are in parallel. Anyone knows the structure of the rear window?
Yeah.
Right?
Yeah.
Like wires like this. It's horizontal, right? The wires are horizontal, and we have two nodes on one node on each side. So they are in parallel.
Okay.
So they are in parallel.
0.22 ohms.
0.22 ohms. You use 1.76 divided by 8. No. Yes.
Total of resistance and divide that by 8, so it's 1.764 divided by 8.
1.6 something divided by 6 divided by 8. Who agree with this? No one agree with you?
They don't just.
You know the problem, right?
Yeah.
The total resistance equals 1.76. We already calculated. Okay? We assume this is correct. My further question is, what is each resistor? There are 8 of them.
8 over this way. This RT, so there's 8. You divide
Hello? Give me an answer.
0.22.
0.22. Use 1.7, the total divided by 8. They all the same. In parallel. In parallel.
Yeah.
In parallel.
No, hold on.
In parallel.
Wait,
Wait. Okay?
means for total resistance, it's 1 over R1 plus 1
It's
over
8.
R2. So there's 8 then.
So the total equals 1.76. There are 8 of them in parallel. What is each one?
1 over
No, it's 8
Eight.
over
Eight.
1.76.
Okay, let's make this easier. Suppose the total is 2. We do not say 1.76. Okay, is 2.
It's 8 over.
There are 8 of them. So just use 2 over 8, right?
It's 8 over 1.76.
8 over 1.76.
Yeah.
That's how I derived it.
Right? There are 8 in parallel. Yeah, horizontal. Right? It will more real. Right?
I still think it's 0.22.
Like this, like this. So this is your battery. And the total equals 1.76. what is each one? We are the same. Huh?
0.22.
0.22. You use RT over 8 equals 0.22. Who agree with this?
Is that, no?
That's wrong.
No, that's
That's
not
wrong.
parallel.
That's a series. That's in parallel.
Yeah, that's for series.
So I said,
Not parallel.
I remind you a lot of time, in parallel.
Yeah, that's
In
series.
parallel.
I don't know how to say it.
Oh, we are coming to this interesting part. Eh?
This is not hard to do. They're all, yeah, you're wrong. And then all the same
This one here should move this to here, this one
Yeah.
to here. This one is the conductance, and this one is the resistance. Right? Anyone? Hello? I need some. Is this good or not?
No.
No. Right? Now everyone, we decided this is not correct because I said it's in parallel. Right? You know this result apply to in series, right? So what is the correct one? This one is wrong. What is the correct one?
Take the reciprocal of that.
Huh?
Take the reciprocal of that.
Take this back. 8 over RT.
Or the reciprocal of 0.22.
Remember before this example we mentioned for special cases if the resistance are identical, if all the resistors are identical, if they are in series, for example each one is 1K, if there are 10 in series, what is the total? You just multiply by 10, right? Yes? If they are in parallel, then you are going to divide it by 10. Yes? If all the resistors are the same, the value equals R. If there are like 100 in series, what is the total? You use each one times 100. How about the resistance if all of them are in parallel? Each one is R, they are 100 in parallel. So you use R divided, each one divided by 100. Does it make sense to everybody? Okay, now look at this one. The total equals 1.76. There are 8 of them in parallel. What is each one?
So it is 0.22.
8 times.
8 times, right? Not divided by 8. It is multiplied by 8.
Yeah. 8 times the total.
14.08.
Does it make sense? Okay, we don't care about the details equals 14 or something. I just make sure you understand you need to use the total multiplied by 8. You can do the calculation, use the calculator easily. Does this make sense? 1.76. The total multiplied by 8. If we know this fact, we can easily do this, then we'll simplify our life later time. Because in a lot of situations, the resistance are identical.
But how can a total be 1.76 and then the individual resistance?
So we mentioned in parallel, in parallel,
Well, it just don't make sense, but I know it's not.
if N resistors
That's what I'm saying, it's just like.
in parallel, in series, then the total equals, if N resistors are identical, right? In series, the total will be equals N times R, right? Each one multiplied by the total number of n.
Yep.
Yes?
Yep.
In parallel, the total will be equal to R over n, right? Divided by n. Yes?
Yeah.
No question? Like this, okay. First one, we have this in parallel. Each one equals 10, 10. What is the total? Total 1 over 10 plus 1 over 10. Then take this one, right? So this one equals 2 over 10, right? 1. So that means 10 over 2. Make sense? So, alright. Better again, right? If there are 2, so the total will be equals 1 over 10 plus 1 over 10, so equals 1 over 2 over 10. Right? So that means equals 10 over 2 equals 5. Right? We don't care that. Right? If there are 3, R equals 1 over 10 plus 1 over 10 plus 1 over 10, right? Is conductance, conductance, conductance. These add up together, so that will be equals 1 over 3 over 10, right? Right? That will be 10 over 3. Make sense? Then if there are 4, R will be equals 1 over 10 plus 1 over 10 plus 1 over 10 plus 1 over 10. That will be 4 over 10. Right? That will be 10 over 4. So you can see if there are total number for n, you just use each one, 10, 10, 10 here, then divide by the total, n, which equals 2 here, 3 here, 4 here. In our example, equals 8. So in our example, the each one divided by 8 equals 1.76. That is good. We are looking for each one. So each one equals 1.76 multiplied by 8. Make sense?
Yeah.
Do not use divided by. Right? I want you to memorize this. Right? Because later time we are going to use this fact a lot of the time. Right? Answer is 90 over 8 equals 11.125. Okay, I said 1.125, which is wrong. This one equals 1.76. That's it. It's very simple. Our question is much more difficult than this one.
Yeah.
What? Oh, it is here. Right? Now you know how to do this, right?
Yeah.
Anyone? Repeat.
Just
1.76 multiplied by 8. See? That's it. Alright, we are good. Okay, now let's review. What is a parallel circuit? We discuss the properties, anything you want to mention about parallel circuit. Oh yeah, circuit in parallel. That is makes a lot of sense, but no sense at all.
And more than one current path.
More than one
current path.
What is it?
And more than one current path. Connected to a common voltage. That's what it said in definition.
Definition. Okay. We don't use the formal word in the textbook. You just use any word how you understand this. This is more important.
More than one path.
More than one path. What else? Any properties, anything useful for analyze the parallel circuit.
They don't say.
Just connected to one source.
They connect to one source.
Yeah.
A parallel series circuit also can connect to one source.
Shouldn't the voltage be the same?
And also, they're not necessary to one source. They can connect to
more than one path.
more than one source.
Yeah.
Yes.
So that is not a unique property for parallel circuit. The number of sources doesn't
The
matter.
number of paths,
The number of paths must be
Only two.
more than two.
more than one,
Yeah.
right?
Yeah.
They must have only two nodes,
Two nodes. Yeah.
right? One is connected to positive, another one connected to negative. There must be only two. If there are more than two, it will be either series or combinational. How about the voltage? Suppose we have several resistors,
It should be the same across all.
must be the same.
Yeah.
How about the current?
Current's different.
The current is divided.
Current are possibly, most probably different.
Or involved.
So how to calculate each current?
The voltage divided by each resistance.
Use the voltage divided by the each resistance.
Yeah.
Right? How about I don't know the total voltage? Instead, I know the total current
And what? And resistance?
and the resistance. I know the total current source. Eh? What you mentioned is if I know this, like this, then I want to calculate each current, use this voltage divided by R1, this voltage divided by R2, you get each current. Okay? That is perfect. Now,
Must be over.
I don't know this voltage. Instead, I know this current,
Total current.
okay? Total current here. How to calculate the voltage, the current on each one?
Using,
Using what? What do we call that? Rule?
I don't remember the name of the
No.
rules, but it's just,
These two divide this total, right?
yeah,
From Kirchhoff's current law, these two add up together must be equal to this one.
yeah.
So each one divide the total. So that is called a voltage current divider. So you still remember the voltage the current divider?
So if you
The
want-
formula? What is I1?
I1 equals R2.
R2 over
R1.
the sum
R2
of
times
this
the total
times the
current.
total. Eh?
Yeah.
If you have more than two, then we know use conductance instead of this one.
Yeah.
What is branch?
Branch.
Branches, each one of the little areas of the resistor is.
Is that a loop? Each
The
loop?
one that
Yeah.
comes out of the node.
Branch means we need to have a source. We need to have like is a loop, right?
It's each individual.
Each individual loop. Like here, how many branches do we have? So here you have this one, you have this one, right? So we can form two different loops.
Yes.
What is Kirchhoff's current law?
So the sum of the currents is equal to the sum of the current leaving.
First one, Kirchhoff's current law applied to what?
Parallel.
When we can use the current Kirchhoff's current law?
There's only two loops.
For only two, we can have more.
Current law.
Current law applied to a node, right?
Node.
Applied to this thing. It's not applied to a path. Kirchhoff's voltage law applied to a path, right? So all the voltages along a closed loop must add up together equals 0. Kirchhoff's current law applied to a node here. All the current coming into the node add up together equals
The amount leaving.
Of 0.
equals 0, right? All the
What's going in is going out.
the sum of all the current coming into, if you leaving, that means negative coming in. We use negative number. Add up together equal to 0. Any questions on this? I hope everybody is clear at this point, right? Because we are going to have a test, right? Very soon. Second midterm. after the combination circuit, which is just a combined series circuit and parallel. So I want to make sure everybody here understand the series circuit and parallel circuit perfectly. Then we are going to have much less difficulty when we discuss the combination circuit. Otherwise, we are going to have a lot of mess. So we need to know the characteristics clearly for series circuit, for parallel circuit. Right? The relationship between the voltage, between the current, all this. What is a node? Everybody read the textbook, right? We didn't discuss what node is in the lecture. Right? You need to read the book. All these slides are summaries, help you to discuss the most important concept in the textbook.
It's worth positive and negative command.
Positive or negative?
Positive.
It's either.
There has to be two notes, one is negative.
Yeah, one negative, one positive, so you have
Yeah,
to,
positive node and
it's like
negative
where
node.
your power comes through and then where your,
Okay.
connected back into your source. Thanks.
Anyone else? What node is?
Or it's the
Don't
connection
read the
between
textbook.
connection in between the two, the positive and negative, where a resistor is connected.
Any point.
Oh, you don't need to know it's positive or negative, right?
Any pointer junction is.
It can be, a node can be anywhere.
Nodes are connected.
What's the junction?
A pointer junction. Any
point
point
of-
or junction in a circuit where two or more components. are
Okay,
connected.
that word is good. The junction. The junction of a device or component. So several components meet at some point. That point is the node. That make sense?
Yes.
Like this one, sorry. The top node, right, we call it A. How many components meet at that point? Two? Three. The source is one, right?
Yeah.
So three components meet at that point. So that is called a node. And the bottom also, how many components? Three meet at that point. Any further questions? So we need to have at least the two components. What is the current divider? For example, you are in the interview, okay? So I'm the potential employer. I ask you, what is current divider? I just ask this general question. You just tell me how you understand the current divider. What is it?
The current coming in
It's
is
how the
equal
current
to
splits
zero.
off the resistors and fails at a
The
voltage.
current in a node.
How current
The
distribute
current in a node.
amongst the components in the circuit.
Right? Everybody, say something. What is current divider?
The current going into the node.
R1,
and the
R2
current
parallel
is
equals-
equal to zero.
Don't look at the formula or the textbook. You just based on your understanding so far. What is current divider?
Current divided among the circuit.
Current divider is something used to divide current,
Yeah.
right?
That's what I was going to say. I don't want to sound stupid.
Okay.
I do want to sound smart.
That is the
I just wanted to.
simplest. Okay, I said give me more details. You give me an example. For example, if you have this device, this
We can use that as an
must be in parallel, right?
we can use that as an example.
Yeah. So this one, first one, you said this resistors, load or anything must be in parallel.
Yeah.
If you are serious, there's no concept of a current divider because all current are the same.
Same in the series.
So must be in parallel. And any properties of this current divider. For example, we know we have formulas to calculate the current on each one. Use a current divider rule. I'm the boss, right? I'm not care about the details. Just tell me something like I can understand. For example, if this resistance is very large,
The current.
what happened to the current?
Current is very small.
It's very small. Good. How small? You know, use the formula to calculate this, right? If this one is so big that it's open,
Infinite resistance. Zero current.
zero current.
Infinite resistance.
If this one accidentally short,
Unlimited current. Unlimited current. Yeah.
unlimited,
Well, very large current.
very large. How large?
Infinite. Too large.
Any number.
Oh yeah. Look at this circuit. Right? You have a point. I know you are correct, but look at this circuit.
Okay.
Yeah.
Right? If this one is short, what is this current?
Zero.
If this one is short,
That's the, and then that becomes.
That one's
you said it's very large. I said how large?
infinite.
Infinite.
Yeah.
Oh, now you have something wrong. Infinite. Infinite does not satisfy the Kirchhoff's current law. Because I know this one coming in here only IF. You said this one equals infinity.
Equals IF.
Equals the source.
Equals the source in this example, right?
Yeah.
So if this one is short, then this one will be very large. How large? In this situation, equals the IS. There will be no current flowing through here. You said infinity, I said that's the point. The point is if you have this voltage source here, like this, if this one is short, then what is the current here?
Zero.
Zero.
Yeah, that one's a short.
This one is short. You have VS here. What is the current here?
Source.
Infinite.
Infinite. Infinite?
No, it's a short.
Source. What's the source? We don't have a current source here.
No, we don't.
That is also.
We have voltage source.
Thing.
So what is the current here?
Infinite.
Infinite in this case. So you can see the difference, right?
Yes, sir.
Does that make sense?
Yes, sir. Yes, sir.
So current source, you can short it. Right? Then this, you short this, the maximum will be just equals this total. Because the total is limited. It is, the total equals this. Then you short it, this one is very large, how large? It is equal to total, all others equal to 0. But if it's a voltage source, you short this one will be very large, how large? Because infinity. So that means if we give you a battery, if that battery is considered as a voltage source, you cannot blank, you cannot what?
Cannot win.
If I give you a battery, right? Everybody has battery. The battery is considered as a voltage source. Suppose this is a battery, it's positive, negative. These two terminals cannot be,
Switch.
still works. These two terminals, you have the AA battery or anything, right? You do not want to put that one in your pocket if you have some case or inside. That means this positive negative cannot be, cannot touch. In academic term cannot be what? Cannot be short. Make sense? If you short this, what happens? The voltage will, the current will be very large. Theoretically, it will be equal to infinity. That means you are going to have fire on your pocket. So that's why you cannot put your batteries on the luggage in airport. That's they worry about. Does it make sense to everybody? So I just came back from travel. They always ask, do you have a smart luggage? No, not smart. Okay. If you have battery, do not short this. If you have a current source like this one, can you short this? Yes, you can, right? It's not good practice, but you can short. That's the danger is small. Does it make sense? I believe this one, you are going to see this kind of situations in real life, in the test, in the homework or something, right? That's the current divider. Now, do this. The total resistance of parallel resistor is equal to
C.
parallel resist. The total resistance of parallel equals the sum of the total, the sum of each one, the sum of the conductance.
Wait, all the, wait.
No, ain't no none. Hey, C.
See,
Oh, that's.
Isn't B right too?
Ain't B. Okay. No,
Everybody? Anyone want first to try?
C.
C, okay. C, can you tell me why choose C?
Because whenever you did the little formula, you said it was.
Okay, let me repeat. You said C, right?
Yeah.
That means that the resistance equals conductance.
Yeah.
Resistance equals conductance.
Wait,
Totally different things. Dogs equals cat. They didn't say one over. It said the total resistance of blah 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 equals the sum of conductance. That means it implies resistance equals conductance. The cat equals dog.
He said K.
So C is good?
No.
B is.
It's A.
No, it's B.
B. Eh? Who says B?
It's A.
Okay. Can you explain?
Because it's in parallel, that means that you gotta use reciprocal, when you're doing in the formula, you gotta use reciprocal.
Okay, let me write this sentence in formula. Let you explain this. The total resistance equals the sum of the reciprocal of the resistance equals 1 over R1 plus 1 over R2 plus more. That is what you said. Right? So is this good?
Then you use conductance.
What is this? Resistance, right?
But it's just a different name.
Yeah.
What is this?
That's the reciprocal. That's conductance.
That's it.
The reciprocal of the,
Okay. The unit of this one equals ohm, right?
Yeah.
What is this? Conductance. S.
So you flip it. At the
So you
end.
add all these S together, still equals it still is conductance.
And then you
That
flip
means
it.
again is that resistance equals conductance.
So C.
That's what I said.
Huh?
So it does equal conductance. Resistance does equal conductance.
Don't say it ain't. You gonna flip it.
So is B good?
B is, yeah.
B? C good? I think it's D.
B means like this.
Yeah.
So this formula is good.
Yeah.
That means resistance equals conductance.
No, it's the,
What?
Is B and C are identical?
Yeah.
B and C are identical.
So they're both wrong. It's A. If B and C are equal, then
it's the
A.
reciprocal of the reciprocal.
Question: is B is equivalent to C?
Yeah.
Yeah. So
The
it's A.
reciprocal of resistance is conductive, right? So B and C are the same. We just conclude that the C is wrong. So B is also wrong. That means you agree ohms equals Siemens. Hess equals Dodge.
it's a reciprocal of the total.
It's A.
It is confusing.
Yeah.
Pretty confusing.
It's A. It's A. Just
So look at the B. The reciprocal resistance, what is it? It's a conductance. The conductance add up together equals the resistance. That is ridiculous. Right? So B is not correct. Now let's look at the A. A, the total resistance equals the sum of the resistance. Oh, it looks good, right? At least the dog equals dog, right? Resistance equals resistance.
Oh, no. The most simplest answer is the answer.
So A is correct. A means 1 dog equals 10 dogs. When you state state something is correct, you must have the same unit, you must have the same quantity. Okay, 2 dogs equals 2 dogs.
There's none.
3 cats equals 3 cats. That's perfect. And B and C said, okay, 1 dog equals 1 cat. B and C is still like this. They are totally different things. They cannot be equal, no matter what the number is. And A means, okay, dogs equals some dogs. That is good, and possibly. But he said the sum of the resistance is not equal to the total resistance for parallel circuit.
It's multiple.
Make sense? A is correct for series circuit, not parallel. So D. Make sense? Who got this correct at the first try?
No one.
Oh, we have somebody. Anybody else? Is this clear or not? Still confused?
Yeah, okay. Just go.
Still confused?
No, you do.
Look at the B. What does that mean? The total resistance equals the sum of the conductors. That is, you don't even need to try. That's like the cat equals dog. No way. It's B and C are the same. Only A is possible, but the number is wrong. And so D is usually. Okay, next one. The number of nodes in a parallel circuit is 1, 2, 3, or any number.
Any number.
Any number. Oh.
I keep getting it wrong.
I think we already understand that all this is perfect. Cool? Cool? Any, who said any?
Have as many as you want, can be as many as you want.
You can have as many, give me a circuit that you have 3.
Wait, no.
No, not 3.
No, it's gonna be
You can have 3
It has to be even. Yeah,
It could be either series or.
How many nodes are in parallel circuit? 2.
I'll say 2.
Who said? I
I
said.
said 2.
You said 2. Anybody else?
I say B.
Any. Okay, give me an example. Said like a.
Hey, man, I said any.
Yeah, any. You give me an example. If you give me an example, obviously yes. Okay? Give me an example. Give me an example of a parallel circuit with which has 3 nodes.
3. Oh, anybody. Go on.
When you're wrong.
Anyone has a 3?
Right. I feel
4?
like it's right there.
Somebody is trying hard. Okay, no way. Alright? No. Only parallel circuit. Do not consider combinational, which will be discussed later time. You can have as many as you want. How many nodes are in series circuit?
One.
In series circuit.
Oh, I don't.
How many nodes can be in a series circuit?
Unlimited.
No.
So the answer is.
How many?
Unlimited, yeah.
2? 10? Yeah. Series circuit. How many nodes? So
So there's no nodes.
there are no nodes. What is node? Node is the conjunction between at least the 2 units.
So if there's no nodes,
Huh.
0.
That's one I always goes over. Always one at the top and one at the bottom.
Okay, how many nodes do we have here?
1.
1, 2, 3, 4, 5. Right?
Those are next.
Make sense? This is this and this meet at this point. It's conjunction between these 2 meet. This one is the conjunction between this. So how many nodes are in series circuit?
Remember the number in series.
As many as you want.
So parallel is only 2.
At least 2, right? Parallel there are only 2. But the series circuit there's only 1 rule.
You go, bro. I got that one right,
We are
man.
better?
Yeah, I'm good.
If you are wrong again, your test. You know what we are having. Okay, this one. The total resistance of this equals okay, I let you guess. Don't calculate anything.
Just guess.
Yes, just a guess. Okay, educated guess. Which one? D.
D 2. If I had to guess, it'd be
You need to go very, when you guess, you need to confident, and not just close the eyes, 1, 2, A, B, C, D. Hello?
Total.
No.
You are engineers, future, right? You are technologists, future, right?
Right. What we got?
You do not bring your calculator at any time. So this one, tell me, what is it?
it's D.
DC.
It's
C.
D. Why would it be C?
I don't know.
Stop playing with it.
Okay, look at this one. You consider the first two, 10 and 10, parallel, what is it?
20. I mean, you said no.
Make
you
me
said-
so disappointed.
You said 10 and 10.
Yeah, 10 and 10 in parallel. This is 2. What is it?
I don't know.
It would be 2 over 10.
2 over 10 or 10 over 2?
10 over 2.
10 over 2, right?
5 and 5.
5. Okay, now 5 and 5.
5, that's 10. And then 5.
5 and 5 equals 10.
No, 5 plus 5 equals 10.
No.
Equals what?
5, he said
Anyone get it?
10.
You don't have to.
So you gotta simplify it.
What?
Huh? 8, right? Okay, 8 is good. Anyone get it?
I'm going to A.
This 10 and this 10 they are identical to, so the total is 10 over 2. So equals 5. Okay? This is 5, these 2 are 5. So you think this one is only 1, now it's 5. This one is 5.1, very close to identical. So you assume this is 5, right? 5, what is it? 2.5. So which one is close?
A.
This one.
Hey.
Whoa.
Make sense?
Yeah.
You don't need to calculate, alright? Just guess.
I mean, so like color codes, but like it's numbers.
Okay, this one. If 3 equal resistors, oh, we like this kind of question, right? Equal, right? In parallel, the total resistance equals 1/3 of the value of each one, the same as 1. 3 times of each one, the product of the 3 resistors. Which one? I'll give you 2 seconds. A, okay? A is good. Parallel, 1/3 divided by 3. This one,
No.
there's no way like this. No matter parallel or series, that both do not make sense. This one 3 times. This is for series. This one again, cat equals dog, right? Because product means almost cubic. So there's no way for this one to be correct. Okay, this one. Any circuit total current entering the node less than the total node equal to the total leaving the node. Greater than can be any above depending on the circuit. Which one?
D.
This one? Boy, right? B, right? Okay, good.
Yeah.
Okay, now this one looks like we got a lot of formulas. Current divider to find I1 for only 2. Eh? Very simple. Which one is correct?
C.
Oh, you are good at this one.
Yeah. Got it. Know that.
You don't need even to think. That's perfect. Alright, this one. Total current is again, you guess, you don't calculate.
B.
B?
B.
C.
Which one?
C. That should be.
You mean this one?
Yes.
How about this one?
No. That's not even possible.
That is not even possible.
Yeah.
I think this one is very possible.
Bro, if that's right, I'm
You are going to what?
I'm gonna lose my mind. How?
No matter what your bet is, don't. Okay, look at this one. This current equals this current plus this current, right? Okay, what is this current? 12 divided by 10, which equals 1.2. This current equals 12 divided by 2, which equals 6. 6 plus 1.2, which equals 7.2.
Yeah.
Yeah? Yes or no?
Yes.
Okay.
I forgot you had to add it.
Alright, next one. What is this circuit? What we call this?
Parallel.
Yes. A more accurate name. Better one. Current divider. Eh?
Yeah.
So what is the current in this one? I'll give you a hint. This resistance equals half of this one.
It's 20 over 3.
So this one will be equals which one?
20 over 3.
20 over 3.
So then A, C over
No, where? You give me one. I depend on you. B.
Depends on you.
Who is B?
No.
Your money. Right? B is correct.
What?
Because it's the small resistance.
The smaller resistor has a larger current. This one is half of this, so this current must be twice as this one. Okay? So this one must be twice as this one.
Yeah.
If this one equals 1, this one will be 2.
Yeah.
Alright, so now, so you can see this one. Good. So you can see a lot of things you don't need to calculate, right?
Yeah.
Okay, this one. The voltage across R2.
See, that would be, wait, oh, the voltage. I'll go with D.
Anyone?
I'll go with D.
You go with D?
I'm not myself that much like I said.
Okay, don't consider D. A.
C.
A equals 0. That's obvious, no. C.
B.
This one is good. Why this one is good? How to do this? Traditional way is, okay, these two combine first. So 100, 200, what is the total?
It's C.
Equals 20 over 3.
It's C, isn't it?
Right? These two combined together. That will be like this multiply, then divided by the sum, so equals 200 divided by 3.
Yeah.
The total of these two. Then you multiply by this
Times it by
one.
20.
So that is 4 divided by 3. That's the total. So that is 1.33. Right? 1/3. Make sense? Everybody get it?
Yeah.
Okay. Last one. Total power dissipated in parallel circuit equal to the power in the largest, power in the smallest, average power in all, the sum of the power in all.
Sum.
D. D?
D.
Anyone says no?
No one.
Huh? No one? Okay, yes. Okay, D is good. The homework is due next time, right?
Yes.
Yes.
I was done for the day. I had nothing else to do.
Oh, no. I thought you said J.